Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on common thermodynamic terms. This will be the first lesson in our third unit, which is an introduction to chemical thermodynamics. In this unit, we will learn about different types of systems and processes used in thermodynamics. Today, we will begin by defining thermodynamics. We will learn about systems, surroundings, and functions. Let us get started. Thermodynamics is the study of energy and its transformation. In terms of chemical reactions, thermodynamics determines whether or not a reaction is possible. It also determines how much product can be formed during a reaction. Students, let us do an activity to get us thinking about energy. Read through the items on the screen and describe each in relation to energy. How do they benefit society?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I hope you found that to be an interesting activity. Common fuels release heat energy. They can be used as a source of heat or for powering combustion engines and steam turbines. Fertilizers assist crops in absorbing light and heat energy from the sun so that the plants can turn it into the chemical energy of food. This is beneficial because healthy crops yield more produce, which helps to feed animals and human beings. Plastics, fiberglass, and ceramic materials function as insulators that limit the flow of energy. They can help us to control the temperature and reactivity of substances. Solar panels absorb light and heat energy from the sun. This is useful because the captured energy can then be reallocated as a source of energy for multiple purposes. All of these energy-related items are widely used in Ethiopia. During the above activity, did you consider that we were discussing systems? Thermodynamic systems can be many things, from a solution in a beaker to an engine in a car. They are a specific region of the universe, often referred to as a physical system, that is studied using the principles of thermodynamics. However, if we are discussing systems, how do we refer to the universe that exists outside of a system? I am sure you recall that energy is not something that can be created or destroyed. Because of this, any loss or gain of energy by a system must accompany an equivalent loss or gain of energy to its surroundings. Surroundings are the physical area that exists around a system. The system plus the surroundings is called the universe, based on the boundary that exists between systems and their surroundings. There are 3 types of thermodynamic systems. Let us discuss each. The first is an open system. This system can exchange mass and energy with its surroundings. This exchange of mass and energy often occurs in the form of heat. An example of an open system would be a glass of water. Let us pretend that you have left a glass of water sitting outside on a very hot day. What would happen? The heat of the surroundings would cause the temperature of the system to increase, and the water would begin to evaporate into the surroundings. Thus, the energy and the mass of the system would be altered. The second is a closed system. It can transfer energy, but not mass, across its boundary with its surroundings. We can use our example of a glass of water again, but this time, imagine that the glass has a lid. The heat of the surroundings would again cause the heat of the system to rise. This would cause the water to evaporate, but since it is a closed system, the water vapor would remain inside of the glass. Therefore, while the energy in the system is altered, the mass is not. Finally, we have an isolated system. Neither the transfer of mass nor the transfer of energy takes place across its boundary with the surroundings. The glass of water would have a lid and it would be insulated. Therefore, the heat of the surroundings would not affect the temperature of the system. Thus, both the energy and the mass of the system remain unchanged. Students, please draw an open system, a closed system, and an isolated system. Then explain what each is.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. The systems that you drew should look like these. An open system is a system that can exchange mass and energy with its surroundings. A closed system is a system that transfers energy, but not mass, across its boundary with its surroundings. An isolated system is a system in which neither the transfer of mass nor the transfer of energy takes place across its boundary with the surroundings. Were those the answers that you wrote down? If so, great work. Systems are said to be in a certain state if their observable variables remain constant over time. An equation that relates these observable variables is known as an equation of state. An example of an equation of state is an ideal gas equation. Thermodynamic functions that depend upon the initial and final state of systems, regardless of how this condition is achieved, are called state functions. Some examples of state functions include energy, volume, and pressure. Functions that rely on the path or the transition of a system from the initial state to the final state are called path functions. Examples include heat and work. In today's lesson, we defined thermodynamics. We also learned about some common thermodynamic terms, including system, surroundings, and functions. In our next lesson, we will learn about the properties and processes of thermodynamics. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.